Today we're going to be looking at the term vertical asymptotes. So what are vertical asymptotes in mathematics? A vertical asymptote is actually a vertical line where the limit of a function actually converges at either positive infinity or negative infinity. Alright, so you can consider a vertical asymptote to be like a mountain, or let me say a mountain this way, that functions continue to climb without getting to the peak. So they can keep climbing the mountain without getting to the peak. And when they try to descend the mountain, they keep descending without also getting to the foot of the mountain. So that is just what vertical asymptotes is about in maths. All right, so we say that a point A is called a vertical asymptote of a function if the limit of a function f of x, lim, of f of x as x approaches a is equal to infinity. And also the point is also called a vertical asymptote if the limit of a function f of x as x approaches the point a is equal to minus infinity. So now you can see that for vertical asymptotes, it is either the limit of a function at that point is positive infinity or negative infinity. Now let us focus on the positive infinity of the limit of a function at that point. You know that the limit of a function is said to exist if the left hand limit and the right hand limit are the same. Alright, so if I say that the limit of f of x as x approaches a is infinity, that means that both the left hand limit and the right hand limit are actually infinity. That is to say that the limit of f of x as x approaches a from the left is equal to the limit of f of x as x approaches a from the right, and everything is infinity. All right, so now let's look at what the left hand limit and the right hand limit is about for a function at a point A. All right, if I have my xy plane this way, and I have a vertical asymptote called A at this point. Now, what it means for the left-hand limit of this function at A to be equal to infinity means that as the function approaches A from the left hand, so this is point A now, this is left of A and this is right of A. So as the function approaches A from the left, the function moves this way towards infinity. It keeps climbing this line without actually getting to the line because the function will be undefined at this line. So that is why the line is called a vertical asymptote now. And also, if the function is coming from the right, as it gets closer to the line, it moves this way and it goes down to positive infinity. So that means that both the left-hand limit and the right-hand limit of this function at this point called A is actually heading to infinity. So in this case now, we can claim that A is a vertical asymptote. All right, let's come to the negative infinity side of the function. A function is said to be having a limit at a point if the left-hand limit and the right-hand limit is the same thing. So that means that the left-hand limit, which is limit of f of x as x approaches a from the left, must be equal to the limit of f of x as x approaches a from the right, and everything should be equal to negative infinity. So let us try to investigate what it looks like now. So if I have my xy plane and I have my asymptote here, so what this actually means is that as the function approaches the point A from the left this way, it goes down to negative infinity. And same thing with when the function approaches A from the right, so it also goes down to negative infinity. So since the left hand limit and the right hand limit are the same thing, so we say that the limit of the function exists at the point A. And that means that A here becomes a vertical asymptote. So now vertical asymptote, like I said earlier, are just like vertical walls that functions continue to climb without getting to the end. So we have a point to be a vertical asymptote if the limit of a function at that point is equal to infinity.